Alright, ladies and gentlemen, with the gentle pitter-patter of the rain in the background, we'll go ahead and start our Module 5 notes. We are going to be taking a look at Mid-Module 5 review today, which I'm overlapping with Lesson 5-9. So, Module 5, Lesson 9, Mid-Module review. We're going to need one less than 10 for our Roman numeral today. There we are, IX for 9. Let's take a look at some of the things we've gone over so far in this module. We'll start with 5-1. We talked about building solids. We did a little bit of review in geometry, but the big focus, the big takeaway for this particular review, I want you to be thinking about the solids themselves. So first of all, make sure you remember what a solid is. A solid is a three-dimensional figure, and in parentheses I'm going to include it should have length, width, and height. I think that's probably going off the screen. Let's slide it on over. There we go. Solid is a three-dimensional figure with length, width, and height. And I know we've done that a few times. It's worth repeating. Okay, sorry, let's put those up there for later. Goodness, pencil's getting in the way. Okay, number 2. A unit cube. All volume is measured using unit cubes. They can be centimeter cubes, inch cubes, foot cubes, whatever the unit may be. The unit cube is a solid, and I will include cube in case that was up for discussion and we were confused. A solid, a cube, whose edges, now I think originally I wrote sides in your other notes. Let's be more mathematical, let's be more precise now that we have the terminology. Whose edges are all 1 unit long. All 1 unit long. Okay. We used the little centimeter cubes in class, but like I keep repeating, you could use any unit of measurement. You can have a cubic meter. You could have a cubic mile. Oh, that's pretty ridiculous. All right, let's move on to letter B. Letter B, we're looking at 5-2, volume and packing with cubes. Volume and packing with cubes. I probably could have just put volume is packing with cubes, because it is. Now, in class, we packed with cubes. We made a solid and packed it with cubes. And the way we did that was by cutting out, well, first we constructed, and then we cut out a net. A net is a two-dimensional pattern. So it starts off flat, two-dimensional. A two-dimensional pattern made of 2D shapes, two-dimensional pattern made of two-dimensional shapes that can be folded to model a solid. So you can fold it up, folded to model a solid. You can fold it up and turn it into a solid figure. Because a solid, a three-dimensional figure, is constructed from a collection of two-dimensional shapes, of flat shapes. Okay. Let's go ahead, we'll go down here, start on this line, go down 4 lines total. Slide this up a little bit, there we go. Go over about that far, we'll slide down 4 as well. Now what we're doing is constructing a net. We are not cutting this out, don't worry. Go ahead, fill that in right there. We're going to put another flap right here. we are going to put an identical flap here. You notice when I'm making this, what I'm really trying to do is kind of mirror. I made this and this at the same time. I made this and this at the same time because they mirror each other. The only ones that are a little trickier are the bases. Right now I've only got one. I will put the other base. It'll hop over that flap. There we go. Now I call it a base, even though really if I were to open this or cut this out, fold it up, what I'd probably end up with is more of a lid. It would look more like a lid. Alright, we don't have to shade that perfectly, but I do want the bases shaded because we're going to talk about that a little bit. I know there's kind of a lot of writing, but don't worry, we'll be drawing more pictures very shortly. These 6 faces, 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. These 6 faces, 2 are bases. We talked about how 2 of them are bases. These 6 faces can fold together. Again, we're not going to, but if we were going to cut it out, they would fold together to make a... Now, if they can make a solid, but we're going to be more specific than that, not just any old solid. If I cut this out, it will make a rectangular prism. And again, that is defined, it's a rectangular prism, because the 2 bases are rectangles. Now, everything else is a rectangle too, and in 5th grade, that's really about all we're going to deal with. But any kind of prism you make will have rectangular sides like this, rectangular faces here, the flaps, but the bases may change shape. Since these are rectangles too, that's why this is called a rectangular prism. Alright, moving right along, let's move on to C, lesson 5-3. 5-3, rectangular prisms. So there's that terminology again, rectangular prisms and layers. Rectangular prisms and layers. Now for this, go ahead and skip a line. Draw a rectangle. Mine's a little slanted, but it'll be okay. Draw a rectangle. Then we're going to go ahead and about halfway between these lines, I'm going to draw the back corner. And then I'll connect. Again, I know I've said this in class. I'm trying to show you a few different ways to create rectangular prisms on your paper, just so you have an option that works well for you. Now I'm going to split this first in half. I'm going to cut right like that. Now at this point, we could even talk about this just being 2 layers, right? Here's 1, here's 2. 2 layers of one big block. But I'm going to cut this up a bit more than that. Slice that in half. Go back, and now, oh, one more thing. I saw the blue line in the middle and I forgot. I am actually going to slice right there too. I'll darken it in so I don't make that mistake again. Go back because the slice would be visible on that side as well. Now most of you can probably count up how many cubes there are. We've got 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 cubic units. I don't know if they're cubic inches, cubic centimeters, whatever. Okay. These also don't look perfectly like cubes. We'll pretend. Now, I can take this and I can look at it. I can visualize it as a collection of layers. And there are many different ways I can do this. I can think of at least 2 or 3 good ones. But we're just going to write one for now. And to do that, we're going to start by once again drawing that same rectangle. We will once again draw that corner over here, and then we'll connect it. Okay. Let me make that line a little bit straighter, a little bit darker. There we go. Okay. So start the same way, split and split, split and split, split and split, and the one I forgot last time, split. Okay, so how does this look any different than the other one? Really, it shouldn't. At least not yet. If I can ever hold these colored pencils, what I'm going to do is break it into layers. Now, like I said, I could do this a few different ways. I could make a bunch of layers of 2. So here's a layer, here's a layer, here's a layer, here's a layer. I could split here and then have 2 layers again, but it would be of 4 cubes each. What I'm going to do instead, I'm sorry, I always turn it sideways when I'm coloring just to make sure it's a little cleaner. When I can pull the pencil towards me, I feel like I get slightly better lines, slightly better color. I'm going to color that. I'm going to color that. And while I'm just being kooky with my art, it's also a good point. It shows that this would work no matter which way I rotate, which way I spin around the solid. But we're back here now. And now you can see, hopefully, we have 2 layers of 4 cubes. I actually said that a minute ago, even though I was talking about a different split. You can have 2 layers of 4 cubes. We can have 4 layers of 2 cubes. There are different ways to do it. The idea is these numbers multiplied together, 2 times 4, will equal the total volume. Because each layer is the same as the base area, and like we've talked about, you multiply height times base area to get the volume. Height, how many layers high, times the base area. In fact, let's go ahead and get to that section right now. Because like most review notes, these are starting to run a little long. All right, lesson 5-4, we talked about multiplication and volume. Multiplication and volume. This is what most of you wanted to do from the very beginning, I know. But exploring with the cubes, drawing these pictures, making the nets, hopefully all of this shows you why volume is equal to whatever the base area is, to your first layer, your base area, times the height, times how many layers high it is. Okay. Now for us, most of the time, we're going to write this as V equals length times width, L times W. And I put those in parentheses. A lot of you have been putting them in parentheses because those two together make a single value. They make the area of the base, the area of the floor, the area of the bottom. Base, base, base. Okay. Volume equals length times width times height. How many layers are there? Now there's one last review section we're going to go through. We spent a little less time on this in class. This is actually for section 5-6. Now 5-6 is just taking everything you've done so far and putting it together, literally connecting it, because this lesson deals with volume of connected prisms. So far I've given you one at a time, and then we split it. Or even this net would only fold into one. Okay. But sometimes you are going to get a prism that does not look like a perfect rectangular prism at all. In fact, it's not a prism, it is a solid. Let me show you. Okay. Let's say I give you something that looks like this. Skip one line, go down and draw a line. But this time, instead of making a perfect rectangle, we're going to detour over and make almost like a big L, like a big boot. Okay, and close it up. Now I'm going to start by putting a corner here just like before, but I'm also going to do a corner down here. Basically, again, I'm creating that second boot. Connect the corners. Okay. Now, how would I find the volume of this? Even if I had length times width times height, it's got a chunk missing out of it. Let's fix that corner. It's got a chunk missing out of it. It's not a perfect rectangular prism. So to do this, split connected prisms into separate rectangular prisms. Split connected prisms into separate rectangular prisms. Okay. Let's do a semicolon. Split connected prisms into separate rectangular prisms. Find volumes. Add. Let me show you. You're going to love this. You're going to have to draw this again. Okay. Let's go skip this line. We'll draw our little boot again. We'll draw our corners again. And we'll connect the vertices again. Stop forgetting that one, Mr. Andre. Now, when I say split connected prisms, what I'm saying is go from here, where everything is solid, one piece, right? Cut it so that you can make individual rectangular prisms. Now, there are different ways you can do this. Okay, I've got my original, right? I don't know how to find the volume of that. But if I split right here, now instead of a boot, I guess it kind of looks like two shoeboxes sitting on top of each other. One shoebox sitting on top of the other, I suppose, would be more accurate. Okay. Now I have two figures that I can find volume for. I can find the volume of the red. I can find the volume of the blue. And when I have those two volumes, I can add them together and get a total volume. Now, that, to me, is the most obvious way to split them. But there's a chance out there that some of you noticed there is another way to do this also. So guess what? We get to draw the boot one more time. This will be it, though. We'll stop after this one. Go ahead and draw your boot. Go ahead and draw your corner. Go ahead and connect vertices. Now, sometimes your shapes will be a little easier than this. Sometimes they'll be more complicated than this. But all you're trying to do is slice it into rectangular prisms. Now, I sliced across, box on top of box. If you prefer, you could also slice down. And now I have one big rectangular prism right here and a little smaller one next to it. Kind of looks like two big high-rise buildings next to each other. Once again, if I go ahead, I find the volume of this, I find the volume of this, add those volumes together. All right, that should be it for that particular lesson. We'll spend some more time on that in class. For right now, I'll zoom out, make sure you have your review notes. That'll be it for us tonight. Go ahead, bring any questions or comments to class, and we will go over them there. Thanks, folks. I will see you next time.